Talking about another polymer, PVC, polyvinyl chloride. The monomer involved is vinyl chloride, or IUPAC name for it is chloroethene. So you have chloroethene. Unsaturated double bond, then again you have many of them, so N is many. You have a number bigger than 10,000 or 40,000. Now this is going to open up, and then you will have a macromolecule, a giant molecule known as your polymer, and the polymer will have the initial name of your reactant, so it's PVC, polyvinyl chloride. It's hard, it's brittle, it's also one of those thermoplastic. By now you should remember what thermoplastic was. It's the one that you can reheat it and change the shape. So it's a thermoplastic. Now what we can do is, but you also have seen vinyl boots, vinyl clothing, shower curtains. What we can do to soften PVC, which is hard, is to add something known as plasticizer. You need to know what it means, and you also need to know on molecular levels sort of what plasticizers do. They're chemicals that you will add it to a rigid plastic or polymer to make it flexible. So that's what is plasticizer. Now what they do is they get between your polymers, and they are going to interrupt the bondings, and they keep them further away. Next slide I'm going to show you one plasticizer and say it has a polar and non-polar ends and what they do. But this interruption on molecular level, instead of having a perfect packing and becoming rigid, having high melting point, now you will have weaker attractive forces because of these plasticizers in between, and you're going to become softened, and we can use it for other purposes. So this is changing property of PVC by simply adding a plasticizer to it. So now one shortcoming with plasticizer is they will evaporate over time. A brand new car, the smell that you have inside is because of plasticizers are sort of evaporating. Eventually over time PVC in a dry place is going to become hardened and it's going to break, and there is environmental concern because this plasticizer gets into our food supply and stuff of that nature. Now let's just talk about one plasticizer as example. They are usually a category of diesters. They have two ester groups. Now remember, ester is C double bond O, C single bond O. Instead of a hydrogen and being a carboxylic acid, it has alkyl group, and this side you have this. So if you look at this, this is a ester linkage and this is a ester linkage. Now they both have each plasticizer has a polar and non-polar groups. The polar is going to lock the plasticizer in the polymer, so it stays there temporarily before it evaporates. And the non-polar group is going to interrupt the attractive forces, and it's going to weaken them. Therefore, the plastic becomes flexible. So that is what a plasticizer is and does. Now, there are some problems associated with polymers, and you should be able to know them. One is that it's difficult to get rid of them. They fill the landfills, and they just stay there forever. They're not biodegradable. Therefore, nature cannot take them back to its raw material that it used to be. So what we are using is we are using our natural resources to give you something that is permanent. After use, there is nothing else we can do to them. Especially in case of PVC, there is another danger. If you try to burn it to get rid of that, it's going to produce fumes that are carcinogenic because they have chlorines. And also it's going to contribute to acid rain because of the chlorine is going to mix with water and give you hydrochloric acid or hypochlorous acid. The last polymer I like to talk about in this segment is polystyrene. So it comes from styrene. Styrene is your monomer. It has a benzene ring, and then it has a double bond attached to two carbons. So this is styrene. It comes in a liquid form. Once you make it into a polymer, when you put them under right pressure and temperature, they will give you polystyrene, which is thermoplastic. Then again, remember, you can remold it now at different temperature. And if you make polystyrene, it's usually your fragile sort of champagne glasses or cups like this nature that they break. But what you can do is change the property of polystyrene also as well by blowing pentane into it, pentane gas or carbon dioxide. But the pentane, what it's going to do is going to sort of expand this into a white styrofoam, and it has a lower density than polystyrene. So you can go from one version of polystyrene to another by changing its property by blowing gas into it, such as pentane. Sometimes they also use carbon dioxide, but carbon dioxide gets released and it's a global warming agent.